Dear learners, how are you finding your journey into the history of periodic table? You have travelled in time zone bus into 1817 Dubonniers Triads, 1866 station number 2, that is Newland's law of octaves, 1869, that was station number 3, yes, Mendeleev's periodic table. I am sure you are curious to know how the anomalies of Mendeleev's law of periodic table were addressed. So once again, hop in my yellow bus and let's time travel to 1913. Tighten your seat belts and hold on to the seat handle. Listen carefully. Till now, all the classification of elements were based on atomic mass. So, elements were arranged in increasing order of atomic mass by Mendeleev. Remember, atomic mass is mass of single atom of an element. Then, with discovery of subatomic particle, atomic number was defined. Can you define it? It is number of protons present in the nucleus of an atom. You must be wondering why Mendeleev did not use atomic number. Do pay attention to one thing. It was discovered in 1900 that atom was indivisible particle and contained at least one subatomic particle, the electron, which was identified by J.J. Thomson. Now again have a closer look. J.J. Thomson was born in 1856. Mendeleev law came in 1869. So what must be the age of J.J. Thomson then? Just 13-year-old boy, and much later he was awarded the Nobel Prize in 1906 for his work on discovery of electrons. So Rutherford's atomic model and concept of atomic number was discovered after Mendeleev's death. Are you enjoying your time travel into 1913? This is your last halt. Come on, alight from the bus. Let me park my bus here. Let's get down from the yellow bus, and you are in 1913. Look there. There he is, the scientist you are searching for. Are you one of the scientists working on modern periodic table? Yes, I am Henry Moseley. Mendeleev, sir, is father of periodic table, no doubt, the originator. I, along with my team of other scientists, have modified Mendeleev's periodic law and have adopted atomic number as the basis of modern periodic table. Now that proton has been discovered, so the atomic number of an element is more fundamental property than its atomic mass, and chemical properties, they were more related to atomic number than atomic mass. So, you know, the modern periodic law is stated as properties of elements, they are periodic function of their atomic number. And let's develop our own 2D and 3D periodic table. As we go along learning it, you will be master of it by the end of this journey. So here is the blank table, like how scientists must have started. So here is a skeleton of empty periodic table. See here, I have kept a very special feature here. I have raised this table by placing some rough newspaper and leftover pieces of chart paper underneath. Now, my visually impaired students can also feel the outline of the periodic table, and they will get a clear picture that this table is not like an ordinary table with regular rectangular shape. It has somewhat different shape. They can feel it. Why don't you also pause here and make a sketch of this in your notebook? Are you ready with your blank modern periodic table? Let's begin with numbering the row. So I am numbering it as 1, this is second row, third, fourth row, 5th row, 6th and 7. So, it has 7 rows. 7 horizontal rows are called periods. So, all these are period numbers. Similarly, we can number columns. Column numbers are going to be 1, 2, 3, 4 and so on. So, let us start writing them. So, now this is the group 13, this is 14th, 15th column, this is 16th column, 17th and this is the 18th column. So, vertical columns, they are called groups in periodic table. So, these are our group numbers. Horizontal rows were periods and vertical columns are groups. Now, let us start numbering the boxes. You can see there are boxes, number of boxes are there. So, well, if I number the box, this is box number 1 and here I am numbering box number 2. In the second row, I have boxes, so I am numbering them 3, 4, this is the 5th box, 5, 6, 7, 8, 9 and 10. Well, now let us start with the third row. So, in the third row, this is box number 11 I have here, 12 and then in the 13th column I have box number 13, 14, 15, 16, 17, 18. In the fourth row, we have box number 19 and 20. We will be discussing in detail till 20, but you may fill others too. And another interesting question which will come to your mind is, can you know how many elements can be placed in these periods? You know you can find that out too. You know how? As of now, recall how can you calculate maximum number of electrons that can be accommodated in a shell? That is right. It depends on the formula 2n square, where n is the number of given shell from the nucleus. Now, for example, if it was k shell, so what do? 2 into 1 square, that means 2. So, hence in first period you saw that 2 elements can be accommodated, and when the filling of L shell starts, so then if you put it in the formula 2n square, you will get the answer 8 as you can see on the screen. Hence, in second period there are, if you count 1, 2, 3, 4, 5, 6, 7, 8 elements. The third, fourth, 5th, 6th and 7th periods have 8, 18, 18, 32 and 32 elements respectively. And the reason for this you will study in higher classes. Now, let us see what decides the placing of an element in a certain group or period. Do you know which is the first element in the periodic table? With atomic number 1 and with just 1 proton in the nucleus. That is right. The correct answer is hydrogen. So, let us put the symbol H in the first box. Here it is already written. Next we have helium, atomic number 2. So, I am putting He over here. Now, coming to the second row, here we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and in the 10th box, neon. And now let me fill up the element in the 3rd row, and I am sure you are also filling it up in your empty periodic table. So here goes in the 11th box Na, that is sodium. So we have Na, and the 12th one is Mg, magnesium. So after magnesium comes aluminium in the 13th box, and note it is in the boron group. And now we have silicon, Si, phosphorus, P, sulfur, S, chlorine, Cl, and in the 18th box is argon. And coming to the 4th row, that is the 19th, we have in the 4th period potassium, K, and then the last symbol I am putting here, calcium, Ca. Well, this can also be used as assessment for learning, where students are told to draw the empty periodic table at home, and they can fill up the groups with colorful drawn circles with symbols of elements written on it. Look here, I have sample over here which my students had done in classroom. They had put these in their portfolio also. So this is one sample, this is another sample of my student, and like this even you can draw and add it in your portfolio. Now what do the atomic number indicate? See these atomic numbers 1, 2, 3, 4, 5, 6 and so on. What do they look like? Serial numbers? Well, to me they look like roll numbers. See on screen, what do you see? I have written atomic number is equal to roll numbers. Yes, a very interesting way of remembering atomic numbers are by relating them to your roll number. I do the same in my class. So every class I take, roll number 1 is hydrogen, and you know what roll number 11 stands for? In my class, roll number 11 is always sodium, and roll number 17 is chlorine. My class is fun and laughter when, while taking attendance, students tell me, "Ma'am, magnesium is absent today." So I mark absent for roll number 12, and my students call each other by the names of elements. And you know what? This way they end up knowing the names of element till atomic number 40 or more, depending on the strength of the class. Well, don't you find this interesting? And what did you observe here? That with every element, the atomic number is increasing by 1. Look here, sodium is 11, then magnesium is 12. So it is increasing by 1. So what does this mean? That 1 extra proton is being added in the nucleus. Now how is the electron number changing? What do you say? Yes, electrons are also increasing by 1. Remember, atom is neutral. It has equal number of proton and electron. Well, though we are going to study till calcium in detail, I am sure you want to know about placement of all the elements. To make your work simpler, here is an interesting science game. This is a team game. Prepare 2 sets of empty outline of periodic table skeleton like this, and 2 sets of 18 chart paper strips with symbols of 18 groups of modern periodic table written on them vertically. See, like this. And now you can place these strips upside down in random order. On saying start, each team members, after discussion with each other, will start placing the strips in appropriate place in the empty box. Well, let me show it for you. This is oxygen family. Well, you will be having an empty box, right? So this way children will learn the placement of each element in the periodic table. Here goes the halogen family. Okay, this is beryllium. Starting with beryllium, I have the alkali metals here. Okay, so now I have learnt it like this, SCTI. So Ti, that means titanium, vanadium. Let me see, here is the noble gases we have, and yes, this is the scandium, SCTiV, then chromium, Cr, Mn, Fe. I am saying out the first element loudly. So I learn it like this, SCTiV, Cr, Mn, Fe, and then cobalt, nickel, copper, and then we have to find the zinc with atomic number 30. Yes, here it goes, and well, here is the nitrogen family. The team which places the strips correctly in minimum time will be declared winner. And well, game for periods can also be played in the same manner. There you can prepare 7 horizontal rows. To make the game more challenging, make sets of strips of groups or periods in which places of certain elements can be left vacant, like the ones I have here. See here, I have left some vacant spaces. This is the noble gas family. Here also in beryllium, then I have left a gap. This is the first group, I have left some gaps. So the teams can be asked to place them in correct position only after they write the symbols of the elements correctly on the blackboard or on the notebook. So here you see that all the elements are arranged in order of increasing atomic numbers. For my children with visually impairment who are equally dear to us, chart paper strips may be transcribed in braille. Children, now I want you to name this game. Maybe you can name it as Find My Home, or give some more catchy title. And yes, you may modify the rules. Maybe you can make small squares of each element and put it in correct position on call out. And let all your friends make one empty periodic table. Play it in your free time with your friends or siblings. I am sure that you will participate in this joyful activity with great enthusiasm. Now, let us recall that the atomic number gives us the number of protons in the nucleus of an atom, and this number increases by 1 in going from one element to the next. Elements, when arranged in order of increasing atomic number, they lead us to the classification of elements known as modern periodic table. Well, the modern periodic table, as you can see on the screen, and compare it with the one which you have prepared. And don't forget to note that in group 6th and 7th, lanthanoids and actinoids, they are also added. So that we have placed it here. And why we have placed it here? Well, you must explore and find out. Now, prediction of properties of elements could be made with more precision when elements were arranged on the basis of increasing atomic number. Let's discuss significance of groups in periodic table. And I am sure you know why we group similar things together. Similarly, elements having similar chemical properties are grouped together. Now let's take a closer look. So let's consider the elements present in the first group. Can you name them? Well, and except for hydrogen, all are alkali metals, as they form alkalis with water. Now let's develop the electronic configuration of first 4 elements of the group. So here let me place nucleus in the center and the first shell, that is K shell over here. I have represented the electrons in the form of these clay. Even you can do it. So if I place one electron over here, well children, this is the electronic configuration of hydrogen with just one proton. and 1 electron. So, how will I write it? In K shell I can write 1 like this. Now, in lithium how many electrons I am supposed to place? Well, 3 electrons. So, 2 electrons will be placed in the K shell like this. Well, I cannot place the third electron here. So, another shell is required like this. So, the third electron goes over here. So, what will be the electronic configuration of lithium? Okay, so I can write it as 2, 1. Now, let us develop electronic configuration of sodium. So, in sodium we have 11 electrons. Okay. So, we will place quickly 8 electrons in this shell. 4, 5, 6, 7 and 8. So, here I have 10 electrons. So, another shell is required like this. Okay. So, can you see the size is also increasing as we are adding on the shell? Yes. So, now let us write it down. So, how am I going to write it? It will be 2, 8, 1 electron in the M shell. Okay. And last one is potassium. So, for potassium let us add more electrons to it. So, quickly I am adding. How many electrons do I need to add over here? It is 2, 8, 8, 1. So, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so where will the last electron enter? Into the N shell. So, well, this is the electronic structure of potassium. Okay, so let us first write down this electronic configuration. Two, 8, 8 and 1. Well, children, can you observe any kind of pattern over here? What all of these have in common? Well, they all have 1 valence electron in their outermost shell. So, their valency is 1 and chemical properties depend on number of valence electrons. Now, here is a task for you. You are going to create your own electronic structures with locally available material, maybe clay or bead. You can put a string or a rope for group 2 and for group 17 and try to find out some similar pattern. I am sure you will find that there is some similarity in the maybe number of valence electrons and valency, and try to relate it that why the scientists have grouped them together in one group. You will find that all these elements contain the same number of valence electrons. Hence, we can say that groups in periodic table signify an identical outer shell electronic configuration. On the other hand, the number of shells increases as we go down the group. But there is a small anomaly in the periodic table. Now, when it comes to the position of hydrogen, you know, the scientists were wondering whether it can be placed in first group or 17th group. Can you say why? Go explore, find out from the internet, talk to your teachers, visit libraries and find out. Now, let us do a recap of what we have learned so far. Anomalies in arrangement of elements based on increasing atomic mass could be removed when the elements were arranged in order of increasing atomic number, a fundamental property of the element discovered by Henry Moseley. Elements in the modern periodic table are arranged in 18 vertical columns called groups and 7 horizontal rows called periods. Well children, you can also exhibit creativity in designing eco-friendly resources, in this case empty periodic table skeleton and science game strips, and further the electronic structure of elements by use of clay or locally available resources. You have taken initiative to know about scientific discoveries and also communicate the discoveries in imagination of time travel into ancient time zone and role play of a scientist. Now here is a task for you. Can you think of some way of designing 3D model of this modern periodic table? Think it over. Go and collect some clay and let me also ponder for a while. Till we meet again in the next part with something interesting, maybe a 3D model. Happy learning!